All right, number 32 on page 462. And this is an equation, an exponential equation, because the variable x is up in the exponent here and here. And I need to solve for it. So I got to be able to somehow get those down on the ground. But this is kind of the interesting thing about this little problem is that it's hard to see maybe at first, but this is actually in quadratic form. This 3 to the power of x, I can look at this first term as 3 to the power of x squared, right? The 2 and the x, they are interchangeable in the order. And then I'm looking at that same 3 to the x, but I'm just looking at a square of that. So minus 10 times 3 to the x plus 9 is 0. When I look at it like this, it sort of looks like a quadratic equation. It's something squared minus 10 times that something plus 9 is 0. So we can temporarily, maybe an easy way to do this is to let that 3x temporarily be represented by u, or 3 to the x power. And then we can write a simpler equation as u squared minus 10 times u plus 9 is 0, which allows us to see how easily this can be solved as a quadratic equation. So I can factor this to be u minus 9 times u minus 1, and so I get that u is either equal to a positive 9 or u could be equal to a positive 1. So now I substitute back in the 3 to the x for u. So 3 to the power of x is 9, and then that's 3 to the x equals, and if I write this as a base of 3, 3 squared. So I could see that x could be 2. And on 3 to the x equals 1, if I want to write that as a power of 3, I could say 3 to the x equals 3 to the 0, because anything to the 0 power is 1. So the other value that x could be is 0. So that's my solution set, 0 and positive 2. And they both check if you check them in the original equation.